42. Yeah?
This is money waste for free.
No, not if it helps you get a good grade. Not money waste. Okay. So in the first one, if the gradient function dy dx is 1 plus x squared, then what is the function y?
Which one?
Oh my, page 42, number 1. Okay, so it says the gradient function equals 1 plus x squared. So how can I get the y? Yeah, it's easy, isn't it? You can just say that y is the integration of this. Thank you. Easy? Okay. You do number 2, please.
Gradient function and the slope function.
Is what?
What is that?
What is what?
Gradient function and slope function.
Ah, this. It's another name. So when I say gradient function or slope function, I also mean this derivative.
So the same meaning.
Same meaning. I haven't started your lab reports yet. I don't want to. I'm too tired.
And we can get below together with final.
Maybe this is better.
When is there like a deadline when we have to get our results?
Too tired to care.
Okay, just give everyone 100.
Yeah. Okay. Have you done number 2?
Yeah.
You can do it in your head, nearly. You have dy dx equals 1 plus 1 over x plus x minus 2. So y equals x plus log x plus x minus 1 over minus 1 plus c. Did you get that? No? No? Yes? Maybe? Got it? Okay. I'm going to do number 3. So what do I need to do for this one?
I'll take the x squared to
Yeah, take the x squared to the right. And then what's next?
integrate.
Yeah, so what I'm doing is I'll separate the dy and the dx. Can you see that?
Yeah.
So now I get dy integrates and x squared and dx integrates. So I get y equals 1/3 x cubed plus c. But this one is different. I can find the c because the question says y0 equals 3. So then that means 3 should equal 0 plus c. So what does c equal? Well, c has to equal 3. So you get y equals 1/3 x cubed plus 3 is the answer. Oh, sorry. Is there any way we can make it higher? but you might need that. I'll do it. No, it's falling apart. Here we go. Me. Oh yeah, perfect. Okay, can you try, do you have this?
Yes.
Can you try number 4? Can I go down? Oh, Hareen!
Yeah.
Where were you Friday morning for your maths exam?
Oh. In my room asleep. It's so funny. My alarm didn't ring.
Blah, 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 blah. Amanda? You were late, weren't you? You came at 12 o'clock for the exam? And Sophie? Okay. Oh, really? You're better now? Were you in the hospital because the doctor told you to go? Or you were in the hospital because you felt really sick?
I feel sick.
Okay.
Even if I take the antibiotics.
Still sick?
Yes.
I was sick last week too. I think yous made me sick.
You've been better today?
Better than last week, but not better enough to use my scooter.
Yeah, but you can drink coffee.
This is like my first cup in like 3 days.
Are you feel good when you drink coffee?
No, I feel very tired. I need to drink coffee.
Do you stomach feel
Just about.
milk?
Oh no, just black, strong coffee. Wake me up.
Really fresh.
Yeah, double espresso.
Yeah.
Okay. Is this one okay, number 4? Can we have a look at it? So what do we need to do first? What's first?
Move.
Yeah, divide x, move x. Yeah, so you get dy dx equals 1 over x. So dy equals 1 over x dx. So then we integrate, and what do we get? Y equals
No.
x plus c. Now y0 equals 1. No, y1 equals 0. And this makes c equal to 0. Okay, so we move down to a more difficult one. I think we all have the idea here, yeah? How difficult do you want?
Intermediate.
Exam difficult?
Good.
8. Well, 8. No, wait, stop. I'll do 8 and then I'll let you do 9 because number 9 was a question I saw on the exam. In fact, it was a question I made for an exam.
You saw.
Yeah, well, I did see it because I wrote it. So 8 dy dx plus x squared dy dx equals 1. Okay, so what do I do first?
Combine the
Take
dy dx with
Yeah.
x squared.
Take out dy dx, so you have 1 plus x squared equals 1, and then we divide. Like this. And then we multiply. dy equals 1 over 1 plus x squared dx. And then we integrate. Anyone know what this is? Oh no, don't check. See if you remember. No? Tan inverse x.
No, I should
Check now.
Differentiation.
Integration, yes. Yeah? So,
Okay.
we're told that y0 equals 0, which means 0 equals 0 plus c, so c is 0. So the answer is y equals tan inverse x. Yeah.
Make it bigger.
Zoom out makes it smaller, zoom in makes it bigger. Okay, try my question number 9.
Not sure.
It's a difficult one.
Why is it not in the formula? Oh, there it is. Never mind.
Which one? Which word are you looking up?
Not.
There's nothing in the formula book that'll help you now.
Wait, even the 1 over 1 plus x squared isn't in the formula book?
Oh, it is.
Yeah, it is
Oh, this one.
1 square.
What about y minus y squared?
It's not in the book.
Okay, then, okay, I can do it manually.
How?
Just flip it. Minus this. Yeah.
Okay.
Let me just do it.
Huh?
Make it math.
What do you mean?
In not input.
What?
Not input.
Okay. So here, are you able to do it?
No.
Oh, okay. I thought you were having a good time. No?
No.
2 more minutes.
I don't believe that you can do it, but okay.
Trust me. Have faith in your students.
Not you.
Try another, not strawberry. If you
Strawberry
want
Ribena.
it- Strawberry rum.
Yeah, that's what I said. Strawberry Ribena. No good?
Medicine takes strawberry.
Yes, yes. Okay, will we do it now?
Yeah.
Yes? Okay. Well, I hope you got the start. 1 over y, 1 minus y, dy equals dx.
Yes.
And then you got this part.
Yeah.
And then next,
1 over 2y minus 1, and then y.
no,
And then
Nope.
y plus
no,
y.
no.
No idea, I'm thinking
This is not in the formula book.
sure.
So you have to product rule.
No, this is not in the formula book. So what you could try is a substitution, but that doesn't work. What you need to do here, just give you ideas. What you need to do here is change this into a over y plus b over 1 minus y. Remember this? Do you remember how to find the a and the b?
This is production.
No, that's not what it's called.
Implicit.
No, it's not called that either. Do you remember how to find the a and the b?
I remember, but I just remember that.
A multiple of minus 1.
I'll do it. 1 over y, 1 minus y equals a over y plus b over 1 minus y. Okay, who remembers what to do here? Yeah?
Multiply.
Multiply, yeah, so you get 1 equals a, 1 minus y plus b, y. Then you make y equal to 0, so then a equals 1. And then you make y equal to 1, and then b equals 1. So in this case, a and b both equal 1. Yeah?
Yeah.
Now we can go back. Go back. Go. Right, so this will be 1 over y plus 1 over minus 1 plus 1 dy equals dx. Now both of these are in the formula book. There's a rule in the formula book for this, 1 over ax plus b. Okay? So there's a rule for these in the formula book. So the first one, I'll just put it here. The first one will be log y, and the second one will be minus, or well, if you want to be very clear, it's like plus 1 over minus 1, because the a is minus 1. Log minus y plus 1 equals x. Now when you divide, when you minus, you divide. Yeah, it's in the formula book like this. This is in the book. And in the book it says it's 1 over a log ax plus b. Okay? So here you get log y over 1 minus y equals x. But what are we trying to get here? Oh yeah, sorry, thank you. What are we trying to get here?
Y.
Yeah, so how can I cancel the log? With an e. So y over 1 minus y equals ex plus c. So y equals ex plus c minus y ex plus c. So y plus y ex plus c equals ex plus c. When you take it to the left. What's next, do you think? y1 plus e x plus c equals e x plus c. So y equals e x plus c over 1 plus e x plus c. You can divide everything by e x plus c. So you get y equals 1 over 1 plus e minus x minus c. Because I can divide everything by this.
In which part divide?
From here to here.
This question, is it in the section A or section B?
I think I put it in section A.
Section A12,
Like A10 maybe, yeah.
then 11 subject what is
No, just when I made it. I don't remember what year I put it in.
Are you making
That's
our
2006.
I am not. When you put this in here,
the fourth student.
I know it's terrible. When I put this in here, I get C as 0. So I'll just put the answer down.
Did you make our exam paper?
I did not. Well,
Yeah.
I made the end of semester 1.
Mhm.
Are you lying to us?
About what? The end of semester 2? Definitely not. Because you would know if it was my exam. You could just tell. You would read it and you could feel it. Yeah.
And can you do more?
More!
The whole thing.
Ah!
Don't worry, I have good vision.
Okay. That was a difficult one, wasn't it? Yeah.
Good.
Can you see what's happening here? It's really just integration. This is a difficult one, but you know, if you can do this one, that's great. It means you know what you're doing.
Great for one time.
Can you read 14 and tell me how to do number 14? And then we'll go to the next page. But I just want you to read 14. Don't worry, it's lots of time. Okay, tell me how to do it.
Move the y first.
Nope,
Divide the integrate.
nope.
What did you just remember?
Double.
Double what? Double espresso?
Divide the x.
No.
No idea. Parallel.
Aaron, your turn now.
I think.
No? Oh, sorry, go on.
First we move.
No. Now, what does that verb mean, verify?
Confirm.
Confirm. What else?
Show that.
Show. What else? Check. So, what I'm saying here is I give you the answer.
Oh yes.
Oh.
E as integrate.
Yes, you just have to
Yeah.
integrate that.
I give you the answer. So you need to show that this answer works. If that's y, what's dy dx? Ex. And what's the second derivative? Ex. So if I put that in here, I get 2ex minus ex minus ex. Does that equal to 0?
Yeah.
The answer is yes.
Did you make this question?
Huh? Funny enough, I also put this question in the exam. True story. Except maybe not this one, the number 16.
How about the grade? There most people do it.
People did as normal. Some did well, some did badly. That's life. Yes? No. Oh, you have the practice exam from Friday. So do you. Did you get the practice exam off it? You got it, yeah? Did you have a look at it?
Yes.
So we
I
don't,
just glanced through it.
Yeah, look.
so
Yeah.
we don't know our answers.
John will do that with you.
So will come.
Yes. She'll be back on Wednesday. Yeah. Do you have the exam from anybody? From Friday? You have it, yeah. Yeah. Okay. We'll have a look now on page 44. So anyway, if you want to practice ODEs, there's lots there to practice. Let's have a look at 44. Now,
It's a long question on ODE.
yes. Now, I'll help you with your English first. So if I say rate of change of y, well, maybe somebody knows. What does that equal?
dy over dx.
You are half right and half
dy
wrong.
over y.
Oh no, it's getting worse.
du,
No?
dy over dt.
dt. Rate of change of y with respect to x. Karen,
Yes.
what does that equal?
dy over dx.
Okay. Proportional, what does that means? This symbol, isn't it? So if I say A is proportional to B, that means A is proportional to B. But how can I change that into an equals? KB, yeah. Yeah. Do you remember this? Did you do this with Joan? Do you just remember this from physics or high school or somewhere in your mind?
Yeah,
Somewhere in your mind, okay. Okay, good. That makes me happy. Okay, let's do an easy one first and then something more difficult. Can I go down? Yeah. So let's read the first one together on page 44. The rate of change of y with respect to x, so look, that's this. The rate of change of y with respect to x is equal to the value of y. Can you see that the first sentence is this? No?
No.
Now you see now, yes? How do I solve this? How do I solve? What do I... Yeah, just, well, I should bring the y to the left and the x to the right. Yes? I integrate. What do I have here? Log y, and here? X plus c. And you're also told that x equals 0, y equals 1. So that will make c equal to, you can see that will be 0. So you get log y equals x. So what does y equal?
Yeah.
Can you try number 2? Number 2? Yeah, what are you asking?
We just leave y here.
Oh, we're finished. This is the end. Grace, once you get y equals blah blah blah, it's finished. But you don't want the c, if you can find it. Oh wait, before you go on, wait. Vocabulary time. What do we call this line with the C in it?
This y intercept.
No, this line, this has a name. This is called the general answer. Yeah? General solution means you don't need to find the C. You can keep C. And this one here with the no C, or the C with the value, which is 0. Does anyone know what that's called? What's the opposite of general?
Exact.
Yeah, exact will do. Exact or specific. Yeah. Okay, now try number 2.
So find the expression for y in terms of x is just exactly.
Yeah.
Integration.
What's integration?
Integration.
Yeah, integration, you're right. Can we do number 2 together now? The rate of change of y with respect to x is equal to the value of y squared. Did you get this? This is called, what's this line called? This is called the ODE. So you get 1 over y squared dy equals dx, y minus 2 dy equals dx. We can integrate. Y minus 1 over minus 1 equals x plus c. So that means minus 1 over y equals x plus c. But y equals
concept of the y can be written down.
I'm not finished yet. But y equals minus 1 over x plus c. I made a mistake, you're right, it can't be 0. I'll change the question here. I'll just say, so this is a change. I'll say y equals 1 when x equals 0. This is a change.
But even if you want 0, the c will equal.
No, I can't make this 0. This is never 0.
Did you change the question?
I need to change it. It needs to say this. So this means that 1 equals minus 1 over c, so c equals minus 1. So the answer is minus 1 over x minus 1. So the answer is 1 over 1 minus x.
So usually means the x. Usually means the x rather than.
Yeah, usually you want like this. X is on the right, y is on the left. This is called the general answer, and then this one here is the exact answer. And this here is called the ODE. I'll do 2 more and then we'll finish, okay?
Can you see our exam one?
These are like number 3 and 4. will do. Can I go down? Yeah. So let's read number 3 together. Number 3 is a common exam type of question. Consider N, which represents the number of nuclei left in some material that is decaying. Okay, now look up. So here is going to be the next sentence. So just listen carefully. The rate of change of N. So what's that? dN dt. Yeah. Is proportional to the amount of nuclei N remaining. Now, how can I remove the proportional? I can get dN dt equals Kn. This is the answer for part A. So have a look, what did they ask for in part A? Find the ODE. By the way, this should look familiar, like you've seen it in, oh, I don't know, physics? Maybe physics? Maybe decay, radiation? Maybe. What is this K like in my maths formula here? Yeah, but what constant? It's like the minus lambda in the decay formula in physics, no? Because remember what this is? This is the activity. No, it doesn't matter. Right. Part B is solve this. So, let's solve it. 1 over n dn equals k dt. What do I get on the left when I integrate? What do I get on the left? Log n equals kt plus c. So I get n equals ekt plus c. So I get n equals ec ekt. Again, let me just tell you, this is like in physics, n equals n0 e minus lambda t. Isn't it? This is like the n0, and this k is like the minus lambda.
This decay question.
It's like a decay question. Right, finally part C. I tell you n0 equals 0.1 and n 5600 equals 0.05. So if I put that in here, I get I'll use a different color now. 0.1 equals E0. So what does what happens to E0? It's 1. So what's EC equal to? 0.1. So I get this answer. N equals 0.1 EKT. Now, have I used this one yet? No. So I can put that one in. And I get 5600 equals 0.1 E 0.05 T. So, if I get my calculator, where's my calculator from? Oh, that's thank you. That's it behind again. 5600 divided by 0.1, log that. Something went wrong.
Did you out a new track?
I thought I did. Wait. What are you? What am I doing? Sorry, that's totally wrong. let's try that again. 0.05 equals 0.1 E K 5600. Now it's right. K equals minus 0.000124. So I get N equals 0.1 E minus 0.000124. There it is. Okay. Doesn't it look like what we did in physics? No.
I remember how.
Yes. Guys, you make me sad. Look. Don't you remember in physics I had this on the board and I said I will prove the formula N equals N0 E minus lambda T. Except on the board I didn't write it like this. I wrote A equals minus lambda N. And then we said A is the same as the N dt. This doesn't look good.
After you write A equals minus
Lambda.
I remember.
Good. Okay, we'll do one more and we'll do it together and then you can practice some at home. I think will be good. So we're going to do number 4. And I think this is good because you're doing with this with Lorraine now, aren't you? Reaction rates?
Yes.
Yeah.
1 hour.
Right, so before you look at it, wait! Look at me. What is a reaction rate?
It's the rate of reaction. It's part of the
Speed of
speed.
the
Bravo. Try again.
The speed at which a reaction occurs.
No, I'm not interested in that definition. You got a different definition?
No.
Getting better. Reaction rate, if you want the exact definition, the reaction rate, it says it here, does Lorraine write or for reaction rate, or what does she write?
She just
Just
write the K and rate.
Okay, I'm going to write or for reaction rate.
Oh,
Now what's
okay.
yours?
She just uses rate.
Okay, fine.
Just rate.
Rate. So reaction rate is, can you see in number 4, is defined as the rate of change of concentration. So what would that be? No, you see, you're thinking chemistry. Forget about chemistry and think about what I said today. So the reaction rate is defined as the rate of change of concentration.
Deconcentration over dt.
Deconcentration over dt. Now, I bet you didn't do that definition of Lorraine, right?
I confused.
No, it's not confused. What I want to show you is the same as what you do in chemistry. Okay? Right, now,
Word is different.
so, what word is different? I have reaction rate equals deconcentration dt. That's my definition of reaction rate. It's the maths definition of reaction rate. Yes? Now, what's the next sentence? The reaction rate is proportional, okay? The reaction rate is proportional to the level of concentration. How do I get rid of the proportional? Reaction rate is equal to K times concentration. Wow. Doesn't that look interesting? Now this is not the definition, okay? This is the definition. This is called the reaction rate law. So this is actually a law, not a definition. Do you understand the difference? Yeah, we can use this to find reaction rate, but it's not the definition of reaction rate. This is the definition of reaction rate. Okay, let's solve this. So, what do I do first? Can I go down? What do I do first? Divide by, bring the dt up and the concentration down. Next, integrate. What's this one? Log concentration equals Kt plus C. So we get concentration equals EKT plus C. Concentration equals EC EKT. Now maybe somebody, what does this part represent? It's just a constant, isn't it? Is C constant? Yes. Is E constant? Yeah. So this altogether is just a constant. So I'll just call it K. Or, well, no, I used K earlier. B or something. But what does it represent? What happens if I put T as 0? What am I left with here when T is 0? We're just left with EC. So EC is A when T is 0. So in other words, you can think of it as like a constant called A0. It's the constant at the start, the concentration at the beginning. Because when T is 0, that's what you have.
So we can rewrite that.
Yeah, so you can rewrite it like this if you want. You don't have to, but if you want. Now, do I tell you what the concentration is at the beginning? Well, it says in part C, initially the concentration is 0.100 moles per litre. Do you see that in 4C? So I have here the concentration is 0.100 EKT. Then I tell you that 1 unit of time later, the concentration is 0.0739. So that means I have 0.0739 equals 0.100 EK. So can we get the K? We sure can.
We remove 1/100. That's all.
Yes, of course. So you get K equals minus 0.3025. So now we have our answer. The concentration equals 0.100 E minus 0.3025 T. This is the answer. So if you were to look, this here you do with Lorraine, right? Except she doesn't write this, she writes, what's it, just rate equals? Yeah. But you now know that rate means this from maths class. So you know this from maths. You don't have to use this. And because you know this, it means you can use your integration and you can get this answer, which means you can get this graph. Here is time, and here is concentration. What unit is concentration? Molars, isn't it? Big M?
Yeah.
And what shape is this graph? It goes down, doesn't it? So it's decreasing like this. Yeah. Have you done this graph with line?
Maybe go to homework.
Yeah, homework has
Yeah.
that.
Ah, well,
Not yet.
no, you have seen it. Yeah. Now, in fact, this is called the first order rate law. What?
Exactly the same.
Yeah, first order rate law, which makes you think, is there a second order rate law?
Yeah.
And what's the difference?
It's
Right,
double
yes.
Squared.
And that is called.
And then third order and then.
Oh no, we don't worry about that. For maths, we just care that it's squared here. Have a look at question 5. The reaction rate is the rate of change of concentration. The reaction rate is proportional to the concentration squared. This is called the second order reaction.
Yeah.
5.
Chemistry makes
Yeah,
And because
it makes it physics.
yeah, well this is it, this is it. Yeah?
yeah.
Now just before we go, I just want to check the other ones with you. So you see in number 6, the growth of a population of rabbits is proportional to how many rabbits there are. Okay, so what letter do you want to use for how many rabbits there are?
PR.
Or for rabbits, okay. So if I say the growth of a population of rabbits, now that's a little bit tricky. When I say the growth, I mean d or dt, is proportional to what? How many rabbits there are? So proportional to,
KR.
yeah, well, proportional to or, so equals KR. Number 7. English person. EAP teacher. No. Zipf's law states that given some book, the frequency f of any word is inversely proportional to its rank. So let me explain that. So, you know the way you have words, and then the words, well, of course you know you have words. Some words are more common. So the most common word is the. So we say its rank is 1. It's first place. The next most common word is of. Its rank is number 2. And then, no, this is just a fact. So I don't know what the next one is. Maybe it's like or something. And its rank would be 3. And so on. So this is called the rank. You know what the frequency is in physics. In maths, the frequency is how many. So like for example, if I have a book of 1,000 words, and maybe I have the word Pokemon, we'll say twice, then that means the frequency for Pokemon is 2 per 1,000. For example, okay? What Zipf noticed is that the rank, what did he notice? Sorry, not the rank, sorry. The frequency is inversely proportional to the rank. Yeah? So the problem here is, well, let me just double check here. Yeah. Maybe that one's too difficult actually. Okay, no, forget about 7. That's too difficult for the exam. And so is number 8. If you can do 5 and 6, that's what the exam difficulty will be. Wow, I made 7 really difficult. No, forget about 7.
You make it?
I made this worksheet. Maybe number 8 is about Hooke's law. Yeah, okay. I think it's too difficult for the exam, maybe. The frequency. Yeah, 7 is too difficult. Why did I make it so difficult?
I think it's difficult.
Maybe that's why I made it so difficult. Right, can you just circle
5 and 6.
5 and 6? If you can do that for Joan. Yeah. Now, tomorrow we have 2 hours of physics, so we'll finish the exam and then we'll start the next exam. Okay. How many hours do we have left of physics? 4 hours. So if I shall try to finish the exam, but do you think you can try the exam at home tonight?
Yeah.
The physics.
Yes.
If somebody like extra physics.
Yes, if we can't finish, can we ask for extra?
Yeah, we can do it in an EAP time or something. Yeah, we'll try and finish it. And then the maths, you have the exam from Friday, and you don't have the answers. John will give you that on Wednesday.
For math, can we have the September?
That exam that you had on Friday was the September exam.
I did something wrong and I took her upset.
You're upset
Yeah.
because you did something wrong?
It's a mistake. I didn't realize.
But that's okay, once you don't do it in the real exam.
That's it.
No. Pokemon Masters don't say this. No. So, tomorrow you have 2 hours of maths, but you won't. Those classes are moved, I think, till Wednesday or Thursday, when Joan is back, okay? So, you are 2 hours free tomorrow for maths.
So can we take physics?
I am teaching the business students. Now, with the business students, I'm doing revision, but I'm doing revision of semester 2.
So semester to business.
Semester 2 business. Now, some of it you have done, and some of it is only for them. So, if you want to go, and you can pay attention when it's important for you, and then do something else when it's not important for you, that's fine. You don't have to go tomorrow. You're free for this time, okay? But if you want to go, you can. Yeah? Alright, so tomorrow please try and have the physics finished. We'll do it in the morning. You don't have maths class, but if you want, you can join me and the business students in maths class. Joan will be back on Wednesday. I think that's everything then. Oh yeah, and you try those 2 for homework then. Okay.